The moment the first pawn moves, the symmetry shatters into a combinatorial explosion that defies human comprehension. By move 3, there are 9 million possible positions. By move 40, we encounter the Shannon number, 10 to the power of 120. To understand the scale of this, consider that there are only about 10 to the power of 80 atoms in the entire observable universe. If every atom in the cosmos was itself a universe, and you counted every atom in those universes, you would still be trillions of orders of magnitude short of the possible games of chess. Yet in the cold, hard logic of game theory, chess is not considered infinite. It is classified as a finite, two-player, zero-sum game of perfect information. Because it fits this rigid mathematical definition, chess is, theoretically, already solved. Every game you have ever played is just a single tiny leaf on a cosmic tree whose root was planted over 1,000 years ago. In 1912, a mathematician named Ernst Zermelo changed the way we look at games forever. He proposed that in any game that is finite, has no element of chance, and where all players have perfect information, there exists a strictly determined outcome. Applied to chess, Zermelo's theorem proves that from the starting position, one of three truths must be absolute. Either white has a strategy to force a win, black has a strategy to force a win, or both players have strategies to force at least a draw. This means that luck does not exist in chess. When you lose, it isn't because your opponent got lucky, it's because you deviated from the mathematical truth of the board. Zermelo's work tells us that if two perfect, godlike computers played each other, the result would be identical every single time. The only reason we don't know that result yet is because the search tree is too vast for our current hardware to reach the bottom. We are like ants trying to map a mountain range by looking at individual pebbles.